Alright, ladies and gentlemen, welcome to our flipped lesson on Skill 3, percent composition. Okay, so what I want to call your attention to is that this formula for percent composition is right in your reference table. It is on Table T, the very back page, and we are going to be dealing with this formula right here, percent composition. Okay, it is a formula that, one, you don't have to memorize, and two, once you get the hang of, is really pretty straightforward. So what we're going to be dealing is the mass of the part over the mass of the whole times 100. Essentially, we are just taking a regular old percentage. Okay, that's all it is. Don't make this more complicated than it is. Now remember, we are going through this over the weekend because we want to deal with Oreos on Monday. So if you can do this successfully, you can deal with the Oreos on Monday. Alright, so ladies and gentlemen, I have written up here the formula, once again, right from your reference table. The percent composition equals the mass of the part over the mass of the whole times 100. So in order to use this formula, what we first need to figure out is the gram formula mass of our compound that we're going to deal with, because primarily when you're given a percent composition formula, you're going to be asked about a compound and asked to say, well, if I have HF, meaning I have hydrogen fluoride, how much of that composition by mass is hydrogen and how much of it by mass is fluorine. And so to do that, we first need to be able to do gram formula mass. So our gram formula mass, we will make sure that we follow the same protocol that we did in class on Friday, and we will break down the molecule. So first I'm going to write my H, and I know that I have one of them, and for hydrogen, my atomic mass is 1. For fluorine, I also have one of them. My atomic mass is 19.0. Okay. And if I add those two up, I get a nice 20.0 grams per mole. Okay. What I'm now going to do is use that 20 grams per mole, and I'm going to calculate the percent composition of hydrogen. So what I'm going to do is call this hydrogen the part, and call the whole this guy. The whole is going to be the mass of the whole compound. So what I'll end up with is my part, which is 1, over my whole, which is 20, times 100. And I will ultimately get the answer that is 5%. So HF is typically 5% hydrogen. You then could subtract 100 and get that fluorine makes up the other 95%, but let's check that out. So if I'm going to do the exact same thing with my fluorine, I say that my fluorine is 19 grams. So I write that out. That's my part, 19. Okay. And then my whole is 20. Multiply the whole thing times 100. And I will, in fact, get 95% as my answer. Okay, so it does add up to 100, so each part adds up to the total of 100%, and that's your nice check to make sure that you did it right. Alright, so we're going to do the exact same thing for BaCl2, which is barium chloride. So the first thing that I have here is my barium and my chloride written out. So I'm going to take a look at my reference table, and I'm going to look up the atomic masses of barium, and if I do that, I'm going to get 137.3. And if I look up chlorine, first of all, I'm going to note that there are 2 chlorines. So I need to say 2 times whatever the atomic mass is of chlorine, which happens to be 35.5. And I'm going to add those 2 guys up right in your calculator, and I'm going to get an answer of 208.3 grams per mole. And this is going to be my whole once again. So now if I'm asked the question, what is the percent composition of barium, I can figure it out because my part is just going to be the barium, 137, and my whole is going to be the 208. So 137.3 divided by 208.3 times 100 will in fact equal 65.9%. And if I do the same thing for my chlorine, I see that I have a part of, maybe you figured it out directly in your calculator, 2 times 35.5 happens to be 71. So it's 71 grams divided by my whole, which is 208.3 times 100. I will get 34.1, 34%. Okay, and you will see it's actually 34.1%, and if I add that up, I will in fact get 100 once again. So now I'm going to ask that you calculate the gram formula mass of magnesium cyanide and see what you get. I will show you the answer up here, so please make sure you check it. Pause for 1 second while you figure out the gram formula mass. Alright, so the answer that you should have gotten is right here. You should have gotten that magnesium's atomic mass is 24.3, carbon's is 12, but there are 2 of them, and then nitrogen's is 14, but once again there are also 2 of them. And so if you sum all of this up, you will get 76.3 grams per mole. So now what we're going to do is calculate the percent composition of the magnesium in this compound, the carbon in this compound, and the nitrogen in this compound. So I will do the magnesium out, and then I'm going to ask you to see if you can figure out the carbon and the nitrogen. So for our magnesium, we're going to take the part, which would be the 24.3, and we're going to take that 24.3, we're going to divide it by the whole, which is going to be our 76.3, and times it by 100, and we will get 31.8%. Okay, so I'd like you to try the carbon and the nitrogen. You can pause right here, come back, and check the answer. Alrighty, our answers here are 31.5% for the carbon and 36.7% for our nitrogen. Hopefully that is what you came up with as well. So now, at the bottom of your page, there are 4 practice questions. Alright, these 4 practice questions. You'll notice that they each give you the gram formula mass in there already. So really the only thing that you are practicing here is being able to use the mass of the part over the mass of the whole times 100 and accurately getting the percentage of whatever compound they're trying to get you to find. Alright, so we're going to do A together. And we've got the percent of oxygen in Fe2SO4. So this is a little more complicated because we have to figure out how many oxygens there are. The gram formula mass is 400. That is going to be our whole. So that's nice to label. And then we need to count how many oxygens. So I've got 4 in the SO4, but there are 3 SO4 molecules, so there are 12. There are 12 total oxygens. Since there are 12 of them, I'm going to multiply it by the gram formula mass of oxygen, which is 16, and that is going to equal 192 grams, okay? Grams per mole, rather. Alright, so if I'm going to set this guy up, I'm going to take my part, which is the 192, divided by my whole, which is 400, multiply that by 100, and I will get my answer of 48%. Alright, so I'm going to skip across, and I'm actually going to do D, because D is a little interesting. This is copper sulfate hydrate, and we are going to talk about hydrates a little more, but I think this is a good question for us to do because it shows oxygen in 2 different places, and we have to be able to account for both of them. Because I'm still finding the percent composition of oxygen. I am still given the gram formula mass, which is going to be my whole. Okay, so make sure you label that. And so now, if I know that I have a whole of 250, the only thing that is for me to do is to figure out how much oxygen I actually have. So we've got 1 oxygen here, okay? However, I see that I have a 5 in front of that, right here, this coefficient, okay? And so that means that I have 5 oxygens there. And then I have an additional 4 oxygens that are here, so that means that I have a total of 9 oxygens. So I have 9 times my 16. And so that means that I have 144 grams per mole of my oxygen. So I'm going to take that as my part. And so what I'll do is take 144 over my whole of 250 and times 100. And that will give me an answer of 57.6%. Alright, so what I would like you to do is to do B and D and pause this guy for me. And when you come back, I will have the answers for you to check. So please pause it right here. And when you have attempted B and D, please check back for the answer. Alrighty, so here are the two answers that you have. Alright, so if you did B and you correctly went through and found that there's 1 oxygen, which is 16, 8 grams per mass of 18 times 100, you got 88.9. And for this guy, please note you are looking for phosphorus, which has an atomic mass of 31.0 over the total gram per mass, which is 149, times 100 gives you 20.8%. Alright, so hopefully you feel very confident with that. Now what I'm also going to include here is an image of the answer key for the questions that we left off with in class on Friday. So if you were not feeling very confident doing gram formula mass and you wanted to check your answers, they are going to be right here for you. So do please take a look at them. Alrighty, so here these guys are. We did a couple of these in class depending on which class you are in. And so these guys are your answers. And if there is anything here that you have no clue how I got to these answers, then by all means, please make a note of them, and we will go over it on Monday, if you so choose. And feel free to email me if you really don't know what's happening. All right, so have a wonderful weekend.